log of 1 is 0. So when x is 1, we have f of x equal to 0, and this graph will look like this. And as x goes to infinity, the f of x is approaching 0. And for f of y, we have for f of y, we have to do it in 2 cases. That is when the first integral will be taken from 1 over x to infinity to y x squared dx. And this will be same thing here, to 1 over this negative 1 over x from 1 over y to infinity. And when x is infinity, it's just 0. So we have 0 minus a minus here. We have positive 1 over 2y times y. And this will be 1 over 2. And now for the second part of the f of y, we have this from integral taken from y to infinity. Take out 1 over 2y as the constant. We have integral 1 over x squared dx. Same thing as what we did before. We have 1 over 2y negative this from y to infinity. And this is 0 minus plus 2y squared. 1 over 2y squared. And this is from when y is larger than 0 but less than 1. And this is when y is larger than or equal to 1. And this graph will be from 0 to 1. From 0 to 1, this will be when y is from 0 to 1, y will be equal to 1 over 2. So this is a half here. And when it reaches at 1, it goes like this. Think of this as just 1 over x squared. It's like the graph of 1 over x squared. So what's the next question? Oh yeah, so this is the graph for f of x, and this is the graph for f of y. So number 4. Verify that f of x and f of y are valid density functions. F of x and f of y are valid density functions. we know that to prove that if a function is a valid density function, we need to take the integral of that function and see if it's equal to 1. And if it's 1, then it's a valid density function. So we have f of x equal to natural log of x over x squared and we take the integral of f of x, we get integral of x over x squared dx, and we see if this is equal to 1. So the range for x is from 1 to infinity, and we have negative natural log of x plus 1 over x from 1 to infinity. And when it's infinity, it's 0. When it's 1, it's just 1. So yes, it is a valid density function. And for f of y, we have when it's 1 over 2, where y is larger than 0 and smaller than 1. The integral of f of y is just the integral of 1 over 2 dy, and this is just 1 over 2y, and y from 0 to 1, this is just 1 over 2. And the second part of f of y is equal to 1 over 2y squared from y is larger than or equal to 1. And this is over 2 squared dy equals this 1 over 2 times negative 1 over y from 1 to infinity. When it's infinity, it's 0. When it's 1, it's minus the negative, so it's positive. It will be 1 over 2 as well. And we add up the two parts, and we get 1. So f of y is also a valid density function.